Today I am going to explain about solubility. Solubility means maximum amount of solute that can be dissolved in given definite amount of solvent at a given temperature. Maximum amount of solute that can be dissolved in given definite amount of solvent at a given temperature. That is solubility. So solubility depends on nature of solute and solvent. Nature of solute and solvent. Second one is amount of solute and solvent. Amount of solute and solvent. Third one is temperature. Fourth one is pressure. How these four factors will affect on solubility. First, nature of solute and solvent. So polar solutes are soluble in polar solvents. Non-polar solutes are soluble in non-polar solvents. Amount of solute and solvent. To solvent increases, solubility increases. For a definite amount of solvent, amount of solute increases, solubility also increases. Temperature and pressure. So now we'll discuss one by one types of solubility. First one, solubility of gas in liquid. Solubility of gas in liquid. So solubility of gas in liquid. So solubility of gas inversely proportional to temperature. Solubility of gas inversely proportional to temperature, and solubility is directly proportional to pressure. Solubility is inversely proportional to temperature and solubility is directly proportional to pressure. So here in this concept we are going to discuss about Henry's law. What is Henry's law? Henry's law. The law states that solubility of a gas in liquid is directly proportional to pressure of the gas on surface of the liquid. Solubility of a gas in liquid, solubility of a gas in liquid is directly proportional to its pressure on surface of the liquid. Solubility of a gas is directly proportional to its pressure on surface of the liquid. So now solubility is directly proportional to pressure. Solubility is equal to Kh into pressure. So this is the final mathematical expression for Henry's law. Here S is solubility, Kh is proportionality constant, that is for Henry's law, that's why it is Kh is Henry's law constant, P is pressure. Another statement for the same Henry's law, solubility of a gas in liquid only, that is partial pressure of a gas, partial pressure of a gas on surface of the liquid, surface of the liquid is directly proportional to its mole fraction in the solution, or pressure is equal to kH into Henry's mole fraction. Here kH is equal to pressure by mole fraction of gas. Here mole fraction of the gas is equal to number of moles of gas divided by sum of number of moles of gas plus number of moles of liquid or water. So that's why, so pressure divided by number of moles of gas divided by sum of number of moles of gas and water. Here number of moles of gas is smaller than number of moles of water. That's why ignore that. Here multiplied by number of moles of water. So when you take this term, kH is equal to pressure divided by number of moles of gas multiplied by number of moles of water. So here pressure, number of moles of gas is inversely proportional to Henry's constant. Henry's constant increases, solubility of a gas decreases. Higher the kH value, lower will be the solubility. Next, solubility of solid in liquid. Solubility of a solid in liquid. So solubility of a solid, again same, polar solid soluble in polar solvent, non-polar solids are soluble in non-polar solvents. So for example, take a temperature and pressure. So solubility depends upon nature of the process, nature of solubility. That is only for solubility of solid in liquid. So if it is endothermic, process, if the solubility is endothermic process, then solubility is directly proportional to temperature. If the solubility of a solid in liquid endothermic process, then solubility is directly proportional to temperature. If the solubility process is exothermic, then solubility is inversely proportional to temperature. And it does not depends upon pressure. Solubility of a solid in liquid do not depends on pressure. Next, Raoult's law. The law states that the partial vapor pressure of volatile liquids in solutions is directly proportional to its mole fraction in this solution. Raoult's law states that the partial vapor pressure of volatile liquids in solutions is directly proportional to its mole fraction in the solution. Now take a mathematical expression. For example, take a two volatile liquids in a closed container. So it has two liquids. One is A, another one is B. So A particles and B particle, those two are volatile liquids, undergoes vaporization, forms vapors of A and B. Those vapors exert pressure. Now the partial vapor pressure of each component, the partial pressure of a volatile liquid in this solution is directly proportional to its mole fraction. Now partial vapor pressure of a liquid in the solution is directly proportional to its mole fraction in the solution. Now Pa is equal to Pa naught into mole fraction. Here Pa is partial vapor pressure of liquid A in solution. X1 is, or Xa is mole fraction of A liquid in the solution. Pa naught is vapor pressure of liquid A in pure state. Vapor pressure of liquid A in pure state. When mole fraction of liquid A is equal to 1, at that time Pa naught is equal to Pa. Next, partial vapor pressure of liquid B is directly proportional to its mole fraction. So partial vapor pressure of B is equal to Pb naught into Xb. Now take total pressure. Total pressure of a solution is equal to sum of partial vapor pressure of individual liquids, Pa plus P. According to Raoult's law, total pressure of a solution is equal to sum of partial pressure of A and B. Now consider it is equation 1 and it is 2 and it is 3. Substitute equation 1 and 2 in 3. Substitute equation 1 and 2 in equation 3. Equation 3 is this one, total pressure, that is total pressure of a solution is equal to Pa. Pa means Pa naught into Xa plus Pb. Pb means Pb naught into X. So this is final mathematical expression of Raoult's law. Final mathematical expression of Raoult's law. So here Pt is total vapor pressure of the solution. Pa naught is vapor pressure of liquid A in pure state. Xa is mole fraction of A in pure state in solution. Pb naught is vapor pressure of B in pure state. Xb is mole fraction of liquid B in the solution. So now sum of mole fraction of A and B is equal to 1. Then mole fraction of B is equal to 1 minus Xa, mole fraction of A. Substitute Xb term in this expression, then Pt is equal to Pa naught into Xa plus Pb naught into 1 minus Xb means 1 minus Xa. Now simplify this. Pt is equal to Pa naught into Xa plus Pb naught minus Pb naught into X. Now take Xa separate. Pt is equal to Pa naught or else take Xa separate, Xa into Pa naught minus Pb naught. Pa naught minus Pb naught plus Pb. This is also another final mathematical expression of Raoult's law. Now according to Raoult's law, the solutions are classified into different types. One is ideal solution, Another one is non-ideal solution. What are ideal solutions? The solutions which obeys Raoult's law at all concentrations. Which obeys Raoult's law. The solution which obeys Raoult's law at all concentrations, in which the interactions between A and A are B and B are equal to interactions between A and A. Example for ideal solution: toluene, mixture of toluene and benzene. And another one is N-hexane and N-heptane. Benzene and toluene, another mixture, N-hexane and N-heptane. Example for ideal solution. Next, another one is non-ideal solution. Non-ideal solution. Non-ideal solution means the solution which do not obeys Raoult's law. Do not obeys Raoult's law at all concentrations are considered are said to be non-ideal solutions. Example: aniline and phenol. Second one is acetone and chloroform, CHCl3. Third one is alcohol, ethanol and water. And fourth one is mixture of HNO3 and water. So these are all the example for non-ideal solutions. Non-ideal solution means the solution which does not obey. Here, ideal solution obeys Raoult's law, right? For those solutions, Pt is equal to sum of Pa plus Pb. Here, ideal solution, non-ideal solution does not obey Raoult's law. That's why Pt is not equal to Pa plus Pb. Now take a differences between ideal and non-ideal solutions. Here, differences between ideal and non-ideal solution. Differences between ideal and non-ideal solution. So first point, which obeys Raoult's law. Which obeys Raoult's law. So here non-ideal solution means does not obeys Raoult's law. Does not obeys Raoult's law. First point, the solutions which obeys Raoult's law, ideal solution. Under non-ideal solution, the solutions which does not obeys Raoult's law. Ideal solution. Second point, interactions between A and A particles and B particles are equal to interactions between A and B. Here, interactions between A and A particles and B particles are not equal to interactions between AB. Change in enthalpy of volume on mixing. Change in enthalpy of volume on mixing is equal to 0. Under non-ideal solution, change in volume. Here change in volume on mixing equal to 0. Change in volume on mixing for non-ideal solution not equal to 0. Fourth one, change in enthalpy on mixing. Change in enthalpy on mixing is equal to 0. Here under non-ideal solution, change in enthalpy on mixing not equal to 0. Examples for ideal and non-ideal solutions already given. So take benzene and toluene, mixture of benzene and toluene. Example for ideal solution. Non-ideal solution, example for non-ideal solution, mixture of acetone and chloroform, CHCl3. I hope you understood. Now, non-ideal solutions. Non-ideal solutions are classified into two types. One is non-ideal solutions are classified into two types. One is with positive deviation. Another one is with negative deviation. So, non-ideal solution with positive deviation. Point number 1, which shows large positive deviation from Rolle's law. Or first point, total pressure of the mixture is greater than sum of partial pressure of individual liquids PA and PB. Here under negative deviation, total pressure is lesser than sum of partial pressure of individual liquids A and B. Second point, interactions between A and A and B, and B and B, A and A, B and B are greater than interaction between A and B. Here second point, interactions between A and A and B and B lesser than interactions between A, B. Third point, change in volume on mixing is greater than 0. Here under non-ideal solution, change in volume on mixing is lesser than 0. Fourth point, change in enthalpy on mixing is greater than 0. Change in enthalpy on mixing is lesser than 0. Example for positive deviation. So alcohol and water. Here negative deviation example, acetone and chloroform, CHCl3. Acetone and chloroform are the example for negative deviation. Now take a graphical representation. Graphical representation for ideal solution. Graphical representation for ideal solution. So ideal solution means the solution which obeys Raoult's law. According to Raoult's law, P is directly proportional to mole fraction. Now take a graphical representation, pressure, partial pressure versus mole fraction. So now on x-axis take a mole fraction. On x-axis mole fraction. On y-axis vapor pressure. So now take a graphical representation for ideal solution, pressure versus mole fraction. On x-axis I took mole fraction, and y-axis I took vapor pressure. So here mole fraction of A is equal to 0. At this point mole fraction of A is equal to 1. When mole fraction of A increases left to right, vapor pressure of A also increases. PA also increases. When mole fraction of A is equal to 1, at that time pressure exerted by a liquid is equal to PA naught. Next, here mole fraction of B is equal to 0. Here mole fraction of B is equal to 1. Right to left, mole fraction of B increases. Mole fraction of B increases. When mole fraction of B increases from here to here, then vapor pressure also increases. Vapor pressure also increases. When mole fraction of B is equal to 1, at that time pressure exerted by a liquid B is equal to PB naught. Pressure exerted by a liquid B is equal to PB naught. Now connect these 2 points. That line will give total pressure of a solution. Total pressure is equal to sum of partial pressure of A and B. This line partial vapor pressure of B liquid. Now how we can draw a graphical representation for non-ideal solution with positive and negative deviation. Same, I am going to take same graphical representation. So graphical representation for non-ideal solutions with positive and negative deviation. So how we are going to draw a graphical representation for non-ideal solution with positive and negative deviation? Simple. Take it 2 graphical representations. On x-axis mole fraction we are going to take. Here mole fraction of A is equal to 0. Mole fraction of B, A is equal to 1. Here mole fraction of B is equal to 1. Mole fraction of B here 0. Left to right mole fraction of A increases. Vapor pressure also increases. It is for ideal solution. When it reaches maximum, that is PA naught. But for non-ideal solution with positive deviation, the vapor pressure is greater than the expected values. Here right to left mole fraction of B increases, the vapor pressure also increases when it reaches 1 maximum, that is PB naught. The dotted line one for ideal solution. For non-ideal solution, the expected value, then total pressure when you draw a dotted line, that is for ideal. For non-ideal solution with positive deviation, total pressure also greater than expected. So this is positive deviation. Next, here take same mole fraction of A is equal to 0, mole fraction of A is equal to 1 here. Mole fraction of B here 1, and here mole fraction of B is equal to 0. So now for ideal solution, dotted lines, that is PA naught, dotted line, here PB, so it is total pressure. So it is the ideal graphical representation for ideal solution. Now for non-ideal solution with negative deviation, then pressure exerted by A is lesser than expected, B also lesser than expected, total pressure also lesser than expected. The actual values lesser than the expected values. Here actual values greater than the actual values are greater than the expected. So now it is negative non-ideal solution with positive deviation and negative deviation. One is with positive deviation, another one is negative deviation. I hope you understood this video. If you understood this video, please subscribe my channel and like and share this video with your friends and comment on this video.